Our session today will examine traditional and agile development from an architectural and algorithmic perspective to show exactly how and why they work in contrast to differences and similarities. If you're already an Agile proponent, this session will give you more material to draw on when discussing the merits of Agile with those who have not yet discovered its benefits. Our presenter today is Damon Poole, founder and CTO of Accurev, a leading provider of Agile development tools. Damon has over 18 years of software development methodology and process improvement experience, spanning from small co-located teams all the way up to 10,000-person shops doing global development. He writes frequently on the topic of Agile development and works closely with Accurev customers, developing and implementing state-of-the-art Agile techniques. He is an avid blogger, so I would highly recommend his blog at damonpoole.blogspot.com. And with that, I'll turn it over to you, Damon.
Thank you very much. Okay, so thank you for coming. Appreciate it, and hope to give you some information about the algorithms and architectures of Agile versus traditional. And this title slide here has a bridge on it, which I'd like you to keep in mind for a moment. That's the Zakim Bridge in Boston, near where I am. Okay, I guess this has already been covered. Nothing new here. Okay, so why are we here today? Well, hopefully one of the reasons that you're here is because either you're curious about Agile development or you're looking for some more information when talking to others about Agile development. Basically, Agile is fairly new. Even though it's been around for a while, it's still not 100% adopted. So a lot of people ask, why Agile development? What's different? Why is it good? How does it work? That sort of thing. So this is something that we do every day in our jobs, comparing things technically and deciding which one to go with. So one of the best ways is to use our previous experience. In this project, I use this technology or this method or this technique. In that project, I use something else, and I think for this project, it makes most sense to do this. So if you haven't done Agile development before, or somebody that you're talking to has not, previous experience is not available to you. Not quite as good, but still very good, is proven ROI in similar circumstances. So if it's generally accepted, or there's something to point to, some evidence that can say that if you're in telecom, that telecoms do that as a case study. If you're doing e-commerce, that there's a lot of e-commerce studies. Okay, that's pretty good. So it's not your previous experience, but it's documented experience that other people have had where it was worthwhile doing. Now on the other end of the spectrum, you've got the hype and buzz. So if you just want to try something new and different, there's no point in listening to the rest of this presentation. Just go and try something new and different. But probably most people don't do that for something as big as changing from traditional development to Agile development. Certainly some folks try it, but I would say most people don't rely on that. And then you have trust. So somebody that is a friend of yours or a coworker or a colleague at another company who you really value their opinion and you've trusted them before and they didn't let you down, perhaps you trust them and they're in similar circumstances. You're in an internal IT shop and so are they. You're in finance, so are they. It's working for them. Okay, I trust their opinion. Sometimes none of these are available. So what can we do? We can rely on the thing that we actually do day to day. This is what we're good at, technical comparisons. So if you're writing code, it's a new situation, otherwise the code would already be there. You're thinking, okay, should I do this or that? Do I use GWT? Do I use .NET? Do I use Silverlight, something like that? What am I going to use? So you look at the various things and you make a technical judgment and you go on. But you need some sort of framework, and today we're going to be doing a technical comparison of traditional development and Agile development using a particular framework. Okay, so what is that framework? Well, first off, let's think about what is software development. What is it that we do every day? What is it that we do every day? We develop software. We do it to automate business processes or make a business process more efficient. At the end of the day, that's what we're doing, automating something that could otherwise be done with manual work. Okay, so software development itself, the very act of developing software, that process can be thought of in the exact same way. And since that's what I do every day, I'm basically creating tools, SCM related, that for Agile development that automate what would otherwise be manual. And so that's a very easy focus for me. So if we were to say that software development had an architecture, what would that look like? What would that be composed of? Well, everybody knows that you have people, process, and tools. Okay, so let's start with the happy people in the traditional project. Maybe not so happy today, it looks like. And then you have the process around there. So requirements go to spec, go to design, eventually we do some testing. And the testing may be manual, maybe you're doing mainline development. You've got a process document that's very thick. And maybe it hasn't been up to date. Right? Maybe it's not up to date, nobody's updated it recently. So you get the people, the process, and of course the tools. Now this may seem like a bit of an exaggeration. Maybe you've never even heard of Agile. But it's exaggerated to make a point that there may be some tools in your stack as you go to Agile development that are really more for waterfall or traditional development. And hardware from 1999, I leave that there because I keep running into cases like that. In fact, the worst case I ran into recently was somebody that, a well-respected software company that was delivering software, production software, from developer laptops. Not the same developer laptop. This was not customer one-offs, right? So it does happen. So that's the architecture that you want to think about. And of course, an important part of that architecture is the customers. When do you get feedback from the customers? When do you give them something that they can give you new feedback on? Traditionally, that's going to be 6, 9 months or more, something like that. So what might a better architecture look like? So again, people, process, and tools, same customers. Now I'm not suggesting that you replace your people here. That's not the point of this. The idea here is you want to make sure that those folks that are actually doing the work, which are 80% of your budget, have the tools, the skills that they need to do their job. So you can support them by, of course, upgrading their tools, that sort of thing, to better suit what they're doing today, whether it's Agile or what have you, and improve the process, which will be the focus of today. Okay. Now, an important point that sometimes gets forgotten is that architecture is not just at your local site. You may have different technology stacks at different locations. Overall, that is your enterprise architecture for software development. Think of all the places where you actually do development and how they interact. Are they using the same process and tools? Perhaps not. And that's a problem. You want to get them as similar as you possibly can. Now, of course, you want people to use the things that are most appropriate for their circumstances, but it doesn't make sense for one group to be using Visual Basic, another to be using Java, another to be using Assembler, if you're all working on common code, right? That just doesn't make any sense. Okay, so let's start looking at the differences between traditional development algorithmically. What are the steps? Where are the loops? Where's the input and output? So in traditional development, there's a very basic fundamental underlying assumption, which is that we have these phases that we go through. Now, this is no different in Agile development. You still have to specify, what are we going to do? How are we going to do it? Write the code, integrate together the code, write the tests, run the test. You still have to do that. However, let's simplify this a little bit. Letters for the various processes. Now, I've got a lot of work that I need to do. Let's say I have 6 specific features, defects, or whatever that I need to put into the new version of the product, or the initial version of the product. Well, it seems to make sense to do all the specification up front, then follow that by a good design document which takes into account everything that I'm going to do, then write all the code, etc. Now, nobody does this exactly in practice, but this is the starting pattern. So there's, traditional development, perhaps modified for your circumstances, but there's still a big difference between that and Agile. So using this, let's take a look at what actually happens here. You get to the design phase, and well, this one thing we're not really sure about, but we need to go ahead because we promised it, and we're not really sure what the design is going to be, but so it's under-designed in this area. Now, if we were just working on that one thing, we might spend more time on it, or if it was optional, we might put it on the shelf and say, we don't really know how this is going to work. We're not going to promise it. We're not going to start that now. But that's not the situation here. We take some shortcuts with the code. Maybe if we had more time, or if we knew how this was going to work, we might do it a little differently, but we haven't seen exactly how this other group's code is going to work, so you take a shortcut or whatever you need to do. Then, of course, you integrate it together, and you write tests. Now, writing tests in this case, maybe just writing the test plan and the test cases. Maybe you're going to do manual testing, or you may automate it. Whatever you're going to do, you have the testing written down somewhere as to what you're exactly going to do, and then you actually do the testing. Now, when it comes to writing the test, you may be getting low on time. So somebody comes along and says, let's do risk-based assessment of what we need to do here. Let's test the most important stuff first. So what inevitably happens, there's a whole swath of testing that does not get done, tests that don't get written, test plans that don't get done. Right? This happens everywhere. It's not just one organization. Many organizations run into this. And then some testing we're going to cut back on a little bit. We just don't have time to work on that. It's not that important. Maybe nobody will even use it. And then, although we have some tests that we might run, perhaps they don't work when it comes down to it, and we need to ignore those results. And at the end of the day, we decide it's not that important, so we're just going to ignore it. And now you've got holes all over the place. And then we ship. Worse, the absolute worst, and I'm sure this has happened to you. I know it's happened to me. It's happened to almost everybody, is you get almost through coding. You're just starting to integrate, and it's no longer important to do this project, or the budget's not there anymore, or the customer went away. People feel like it's not getting anywhere. There's a new great incentive, and the thing gets canceled or shelved anyway. So you've done all the specification, all the design, all the coding, and you have nothing to show for it. It doesn't work yet. Nobody knows if it'll ever work. It gets lost or forgotten. And then perhaps when the project is taken up again, it started from scratch because things have changed and different people and all that sort of thing. All that work gone. So let's take another look. Let's look at another aspect here, which is the difference between how people are leveraged in traditional development versus Agile development. Now, traditionally, you've got this telephone game, if you will, where the customers and the product managers talk. Now, you may not have a product manager. Perhaps you have a team lead who is a domain expert. Perhaps you have a business analyst. But there's somebody that basically, it might even be a committee, there's basically a process that you go through to decide, what are we going to build? Why are we going to build it? Who are we going to build it for? Perhaps you have a single internal customer, so that's very easy. The product manager, I'm just going to call it product manager here, comes up with a requirements document. It takes him 2 months to actually put it together and get it all cohesive, something that he really wants the architect to see. Now, the architect has questions. He goes to the product manager and says, I have a question about this. Could you clarify that? Well, it's been 2 months. The product manager says, I don't see it in the document. I'm not really sure why I wrote it that way. Seems like I skimped a little bit. Let me call the customer. They call the customer. Now it's been 2 months since they started this project, but that customer they talked to even longer ago. The customer says, I don't even remember asking for that. So memory is not being leveraged here, and the conversation between the customer and the product manager cannot be easily relayed to the architect. And this happens again between the architect and the developers, and again between the developers and the testers. So the architect works for, and you may have multiple architects, you might not have an architect, but there's a design phase that happens here, resulting in design documents. You go to developers, and that takes a while. Meanwhile, they're working on some other project, or whatever your situation is. Developers toil for, let's say 4 months, and then they give to the testers, here's the list of things that we did. And the testers, if they've been proactive, have already looked at the design documents, already looked at the product requirement document, or marketing requirement document, or whatever you call it, the requirements, or the issue tracking system, or whatever you have. So they have some knowledge up front, but they didn't know what to test for a long period of time. Finally, we're going to give the product to the customer, and it's been 9 months since you talked to the customer. Now, of course, your mileage may vary. It may well be that features in here came from even longer ago that now have become strategic importance or tactical importance, and actually you talked to the customer even longer ago. Or perhaps you refreshed and said, okay, you asked for this, we're going to do it. What is your thinking today? In contrast, if think of that as the algorithm. The algorithm for Agile development here, and we'll get into this in more detail in a moment, is that there's a team. Instead of having silos, there's a product owner in there who may very well be a product manager or working with a product manager or a business analyst. But in Agile, there's a role called product owner, and that person is responsible. We'll get into that more in a moment. So as a result of those conversations, he puts together what's going to be in this iteration, which may be 1 to 4 weeks. They work on that, and they deliver it to the customer. Now, a little bit more about this team. If you have a very large team, you may break that down to several Agile teams. Within a team, they're going to be assigned a project or a list of work, and that team needs to have everybody on it that's necessary to get that work done. So a QA person in that team, if you need a DBA, then a DBA in that team. In some cases, it may not be realistic. Maybe you have 2 teams and 1 DBA, and they both need a DBA, so it's going to be shared. But you want to avoid, Agile says avoid sharing. That's part of the architecture and algorithm of Agile development, to avoid sharing. That's part of how it works. You're going to have dedicated developers on that project. You're going to have a dedicated product owner and Scrum Master. Basically, they're going to operate as an autonomous entity, just like a company unto themselves. Okay, so not only is the time between talking to the customer and delivering to the customer very short, and perhaps that delivery is a demo or a beta or just a conversation, we get this working and have some questions for you, your feedback loop is 1 month. Now, if you remember from grade school playing the game of telephone, it's very difficult to get the exact right message through a long chain, and that was just over a couple minutes. Think about it over 9 months. It's a long time. Misunderstandings can grow in that time between the different folks there. Okay, even better, the time between when a developer does something and somebody in QA and a doc writer gets it could be on the order of days. So there's a concept here called one-piece flow. A developer starts working on something, he gets it to completion, writes all the unit tests, makes sure it works. The test person, does additional work there, exploratory testing, additional unit tests, test automation, whatever it is. That task is going to be complete within a couple of days, and then he's going to work on the next thing over and over again. So I ran into this the other day. Somebody came and asked me about an obscure thing that had not really had testing and documentation finished on it. Hey, it happens. And asked me a question I just could not remember. So we struggled to figure that out. I'm sure that happens to you. Just think about the last time a tester came to ask you about something that you developed a long time ago, or even a month ago, or you're the person asking, or let's say you're in management. You say, hey, how could this have happened? Well, think about the dynamic there. If there's a long period of time between when you start working on something and when you start testing it, sometimes corners get cut, and that's what happens. Okay, so let's take a closer look at what happens inside an iteration from an Agile perspective. I'm not going to compare and contrast this with traditional, a full traditional model, but just as I go through it, for each step, compare it to traditional development. So first off, you have a backlog in Agile development. This is a list of everything that anybody has ever asked for. Now you may bucket it into 2 buckets. The stuff that has a chance of actually shipping in the next year, and everything else. Maybe from a strategic perspective or what have you. Or maybe you start a new backlog. Okay, so everything that anybody might want, including defects, any work that anybody's going to actually do to deliver to a customer that has value is going to go into that backlog. Mostly it's going to be composed of stories, but you may have some defects in there as well. Okay, now this is managed by the product owner. In contrast, in traditional development, you may have an issue tracking system that just has everything that anybody's ever asked for completely unordered. And having a P0, P1, P2, P3, P4, let's face it, that's completely unordered. Because all you're doing is you're saying, I've got a whole bunch of stuff that I need to do, and then everything else. And within that P0, you may have a lot of stuff. So that's not really prioritized. So the product owner is going to top to bottom order them, and that order is going to stick. Right? So I can always look at that backlog, and it's going to be ordered by business value. Now that may be revenues, it may be profit margins, it may be cost, It may be some other measure that's important to your stakeholder. But whatever the important metric is, the things that are high value according to that metric are going to be at the top, all the way to the bottom. From that, the product owner, perhaps in conjunction with the product manager, will create a release plan consisting of multiple iterations. Start working on the first iteration, take the user stories in there, and I'm not going to go into detail here, but basic idea is you want to describe it from the user's perspective. So as a user, I want to be able to order with a single click rather than use GWT to implement a dialog box that has a Order Now button on it. That way, it's very clear what the user is looking for, what the value to the user is, so that everybody involved understands that. So those are the user stories in that iteration, which the team works on, the whole team, remember. And from that, they're going to produce the changes that fulfill those requests and the tests that go along with it, unit tests, stress testing, automated tests, whatever it is, test plan. That's a month's worth of work, or perhaps a week. It can vary from 1 to 4 weeks. Sometimes people have iterations that are a little longer, but 1 to 4 weeks is generally best. That's the work done. And from a management perspective, we're going to get a burn down chart or other charts like burn up charts that show us progress. So we can feel confident that we're going to hit that goal or not. Right away in that month, sometime within that month, we can find out that we're running into trouble and we need to change the plan, or that we need more resources, or whatever it is. We know right now. Produce the product. Now, that doesn't mean we're going to necessarily release. That means we have something that could become the product. We have the bits needed to actually run it, demo it internally, test it internally in our test environment or what have you. And we could start the release process, but that's a separate choice that we're going to make. So in Agile, the iterations and the release time frame are completely separated. Lastly, the product owner is going to get involved again here at the end and say, okay, here's what we decided to do for this sprint. Let's review. Show me this work. Show me that work. Now, if it's not a visible thing, it may be as simple as showing the results of the tests, that everything's passing and that the tests are there for that task. Or perhaps for some things, the product owner relies on QA folks to see that that defect has actually been closed. Perhaps they just want to see behavioral changes. In any case, you have a list of what needs to be reviewed. So right at this point, if you have any problem, in this case there's one problem, you know it right now. Instead of the short runway at the end of the release when everybody's panicked and you've got all these problems to deal with. You get to see problems right away and fix them. All right. So I've talked a lot about short iterations. And often people will say, well, you know, all these claims and benefits sound really great, and it seems like a good way of working, and not relying on people's long-term memory seems like a good idea, but I don't see how my project can fit into a short iteration. I mean, first of all, everybody knows that you don't do testing until the end because it takes a long time, and if you try to do it all the time, it won't be well leveraged, it won't be efficient. Part of that is around automation. If you've been doing releases over a long time frame, then doing manual testing on a regular basis doesn't make any sense. And the economy of scale seems to make sense. So part of the difference architecturally there is if you're going to do short iterations, you have to make changes, and test automation is one of them. So even more motivation for those folks that are pushing for test automation. Another soapbox to stand on there. But let's also look at how we think about this. So we have all these tests that we can do. Those are the arrows. We have unit level, integration level, and system level problems and tests that we can run and problems we can find. So if we do it all at the end we have visibility into where the problems are, but not all of them, because often problems will hide other problems. So we have to find and fix, and find and fix, and find and fix. Some of the finding and fixing is just that we couldn't find problems because other problems got in the way. Some of it is that the fixes actually introduce new problems. So we're doing all this finding and fixing at the end. Now, wouldn't it be better to be doing the unit tests as often as you possibly can, such that when you get to integration level testing, the only problems left to find are integration and system level problems. You don't have to contend with unit level problems. And then, if you can, let's get those integration level problems out of the way such that when it comes time to do those expensive system-level tests, if that's the case for you, the only problems left to find are the problems that can only be found at the end. That's going to make that test cycle at the end much smoother. Okay? Another thing to look at is, do you really have all this work that cannot fit into a short iteration? Because remember, the architecture and algorithm of traditional development is I've got this long time frame. I've never had to look at it that way. I've never had to look at how many things do I have that are small or big or what have you. So let's take a look at it. Here's a typical year in development. Now, right now, this is showing 10 months. Each one of these increments is a month. And I'm going to say that you may have one or more major releases. That's the major release. Some testing related to that. One or more minor releases over that period, and then some testing for that. So typically, though, what your year is going to look like is not just this, but also feature creep, our good friend. Well, it's going to be a long time until the next release, so let's just fit this one or two more things in to get that deal or to make that executive stakeholder happy, whatever it is. Because you know what? If he has to wait another 9 months, he's going to be really upset. That's probably going to affect my bonus. So,
hey, Damon, I'm sorry to interrupt, but it looks like, could you refresh your slide?
Yep. Can you see it now?
We still see the test pattern slide.
Okay.
Oh, actually,
it says I've gone off the air.
all right, your slide just changed again.
Okay.
All right, I think we're good.
Okay.
Thanks so much.
It should now say unplanned test and fix.
Yeah, it does.
Okay, great. Thank you. Sorry for the interruption. Must have been a bug there somewhere. Okay, so then of course we have the unplanned test and fix. We all swear up and down at the end of the release that we're never going to have unplanned test and fix again. We're going to have more discipline this time. You know, we're going to do it right. And, you know, cycle after cycle, that pattern repeats. So let's face it, we're going to have unplanned test and fix. That's more time. So all this bit at the end, that's what I call Agile the hard way. Right, so you've got the feature creep, that's by definition small stuff. You've got your test and fix, right, so the fixes you do during that period are small stuff, including the unplanned test and fix. Minor releases, well, that's minor stuff, small, and the testing for that, small. Right, so most of the stuff in a typical year is small. It's Agile the hard way because just doing small increments does not make you Agile. So, you know, all of the safety nets and techniques of Agile, if you're not using them, means you're doing what Agile does the hard way. So what do you have left here? You've got your major stuff, the big stuff. So that's a bunch of work. Let's take a look at that. So if you've never looked at that and just assume that it's a lot of big work, right, let's take a look into this closer. So we've got a whole bunch of tasks here. Some really are a long time to do them. It's just a lot of work that needs to be done, and there's no getting around it. But a lot of the tasks are going to be defect fixes. You know, we plan to revamp this area. That's a lot of little things that people have requested, all in this area. We're going to completely re-architect this piece, what have you. Let's change this view a little bit. Let's rearrange them. So now we can see we've got a whole bunch of little things clearly fit, some bigger ones, until finally we have some things that are going to take about a month, and they'll just barely fit. And then we've got some really large stuff. All right, so still, this is not gonna work, right? We have some things that are going to take 4 months, so we might as well do a whole bunch of other things during those 4 months. But what if you try to break it up? Just, you know, very simply see if there's anything here. If you haven't had to do it before, then if there was something where you could do it, why bother? Let's just do it in the 4 months. So let's break up some of these things. Okay, so I broke up a couple. I've still got some really big stuff in there. So this Agile thing's still not going to work for me. What can I do? Let's look at one piece here. Because remember, with traditional development, the algorithm, if you will, is to find out how big things are, just assume that they are that big, and go from there. In Agile development, the assumption or the algorithm is, how small can we make it? What is the smallest thing that we can deliver that has value to the customer. Right? Because if you actually need two features, plus and minus, just delivering plus may have some value, but if you really need minus, then plus and minus is the minimum thing there. Okay, so let's look at one piece of this. Let's blow it up. Because one of the things you probably were thinking is, I can't just rearrange these things willy-nilly, Damon. You understand that there are dependencies in there. Okay, fair enough. So let's say there's some tasks in here that have interdependencies, and that's one of the reasons that they're too long. And there's also some that are just plain long, longer than an iteration boundary. Well, with a little bit of effort, you can rearrange these so that the dependencies match up on an iteration boundary. So in this case, you have something that has value, but you feel like without the other feature, it's not going to, you just don't want to ship it. Okay, fine. Let's rearrange it so that after a month, for the most part, what you've got is done, usable, installable, testable. There's nothing missing. It has high quality. There's just something else that you want to do in conjunction. Great. So now we're going to have the advantage of being able to get feedback, learn from our mistakes, make the other part even better based on the feedback we've gotten or the things that we've learned, the problems we've run into. But I've still got that one thing that doesn't fit. Now what can I do? Now, it's not the case that I'm going to show you all the techniques for breaking this up. You may still run into problems. And one technique that I actually don't have here on the slides is you can do parallel iterations, where the big stuff is in one branch, if you will, and all the little stuff is in another one. That's one technique. Generally, it's not used for very long. So let's look at that big thing that could not fit. Now, one of the reasons that it can't fit, say it's 28 person days, is that if you look inside it, it's actually a number of tasks, one after the other, where you don't really want those in the code or going to the customer unless that thing at the end works. Because perhaps it's a performance enhancement, and you don't know if it's going to work. So you have to do all this work, and then at the end you can test it, and either it will work or it will not. But to get a straw man together to see if it's even going to be feasible may not require some of the pieces, some of the functionality may be completely superfluous from the perspective of that big value at the end. So if we look at it in more detail, the dependencies may be between part of a task and part of another task, and that doing those things that are required to get to the end are much smaller. So all the things that I've highlighted you do first. You say, hey, this is going to work. Okay, now let me finish it and go back and do the other things that don't have as many dependencies. That's one technique that you can use. Okay, so hopefully what I'm doing is shedding some light on how these two techniques or algorithms, if you will, are different. I may not convince you, but the idea is here is a different framework or way of looking at things that you can use your decision making for making technical decisions on a day-to-day basis to evaluate them. Let me give you a concrete, if you will, example. Getting back to the bridge that I showed you in the title, this is the Zachem bridge on the right. Now, something that I noticed when I first put this presentation together that I hadn't noticed when thinking about this bridge in the past is that while the Zachem is an architectural marvel, it has cantilever and suspension, all kinds of things, very fancy, one-of-a-kind bridge. If you notice on the far right, it's got 2 extra lanes tacked on. Oops. Okay, so that's not my major point here, though. There's a concept in Agile development called the simplest thing that can possibly work. Now, often that gets translated into take shortcuts, low quality. I love this picture because it has an example of the simplest thing that can possibly work, and I'm going to go into this in a little bit more detail in a moment. So on the right, the Zachem bridge, cost per lane, $11 million. Just to the left is the simplest thing that could possibly work. Now, you could make it out of wood, but it wouldn't meet the minimum requirements of spanning this water, spanning the river, and being able to last a long time. This is not a temporary bridge. They intend that to be there for a very long time. Okay, so the simplest thing that can possibly work, not trying to make a landmark here, is the bridge on the left. It's only 4 lanes, but the cost per lane is $5 million. So you put a couple of those across, and you're going to have half the cost. Now, part of the requirement for the Zachem was to be a landmark. And if that's one of your requirements, you can't get around that, and this may well be an example of the simplest thing that can possibly work. But often in software development, we get caught in the trap of let's make something really wonderful that fits all needs for the future, whether we know what they are or not. We're only going to get one shot here. Let's make it really great. And that ends up being more expensive than building the simplest thing that could possibly work and then adapting it as your needs change. Now, if one of your needs is to support millions of users out of the gate, then the simplest thing that could possibly work, which is a Perl script in CGI bin or whatever, that's actually not going to work. You're going to need something a little heftier than that. Okay. Now, the other thing here is you may think, aha, you're telling me that I should not have a beautiful user interface. Nope, I'm not saying that. If you need a beautiful user interface, you need it. But the invisible parts that people don't see, let's do the simplest thing that could possibly work. Okay, so in a little bit more detail here. Traditional development, we know what the highest value is, and that's that green block there. And then we want it to be full featured, because we know it's going to be a long time before we have a chance to do any of this again. And we don't want to disappoint the customer. We don't want them complaining for a long period of time. So let's take a guess at what makes it full featured. They asked for this, but we think they might need some other things in this area. And they're probably going to ask for one of these. We don't know which one. Let's do them both. Now that we've got all this code written, it seems like there's some things in common, and maybe we've got some architecture we need to do here, or a framework we need to develop. And let's not get too carried away, but it's going to take some time. Plus, not only might they need these features, we want to future-proof all of this. We want to make sure that we've taken into account all possible performance ramifications. We want to make sure that we've done everything we can to make this future-proof and complete. Now that we've got all this extra code, we're going to need even more architecture. And let's say that each one of those functional areas, features in these functional areas took a month. So that's 9 months of work. On the other hand, so it's all, when it's done, the whole unit is done. You can't use parts of it until it's done. It's all ready at the end. We get the feedback at the end. In contrast, the Agile algorithm here is, let's do that simple thing first. Let's do the thing that the customers ask for that we know has value. Give it to them as soon as we possibly can. No shortcuts. It has to work. It has to be high quality. And maybe we ship it. Maybe we just give a demo or a beta or what have you. We get feedback. We do the next thing. And that's going to be just a month later. Right? In contrast, we've still got 8 months to go with the other one before we get any feedback at all. They told us that they really liked that thing that we did, but there were a couple little things they wanted different. And there was this new feature that is just a must-have at this point. So we do that, and we keep doing it again and again. Within the same time period, we now have, at the end, we have something that's more mature, more towards what the market or the customer wants. We've gotten feedback every iteration, and we've had a chance to replan every iteration. Oh, we thought this was important. It turns out it's not. Good thing we didn't write that code. So this is also an example of, much with the bridge, what is the simplest thing that could possibly work, and then we evolve it from there. A big difference here as well is that in traditional development, we write our code such that we're hoping it won't change. Right? We want to put off the inevitable. But you know what? The next major release, we're going to have to make some more changes to take into account the next year of development. And if the code is not written to take change into account, it is going to be tough to change. It's going to, handcuff us into certain ways of doing things that the customer might not actually want us to do. In contrast, in Agile, we're going to anticipate that we make change. We're going to write our code such that it's easy to change. And you might think, well, it's a lot of extra work and all this refactoring is really rework. But there's nothing worse than doing a whole bunch of work and sticking it on the shelf because nobody wants it. So making a few changes is much more efficient than not shipping anything at all or making major changes or not being able to respond to the customer. So let's bring it all together here. Side by side, traditional development and Agile. So we're going to look at a 6-month project. We're going to have the exact same circumstances in both cases. We start out with the highest business value being a Facebook plugin, Second Life plugin, and RSS feed support. And engineering says you can have it out here. We do the preparation work, and the market changes. So marketing is now saying, maybe don't spend so much time on Second Life, and support for photos over SMS is really hot. Well, not much you can do now. You're committed. You write the code, things change again. Marketing really just doesn't talk about Second Life support anymore, and they want to know when they can start selling photo SMS. Well, you write the test because you couldn't really write them before because you didn't know what was actually going to come out the other end, and you start running the tests. Market has changed again. And now marketing is livid that they don't have photo SMS. I mean, they told you 6 months ago. What's the problem? Then you've got this long testing period, which is over time. Now, the reason for that is you've been building up technical debt without knowing it. You had no way to know because you didn't have the tests and you hadn't run them. And, you know, of course that's a generalization, but more or less it's true. So you start testing and fixing. First fix makes things worse. You do some more testing. Eventually, you give up and you ship. All right, let's call it a, it's getting pretty good. Let's ship it. Now that test period at the end, again, it's not that long because actually running the tests take that long. If you think about it, whatever you shipped, if you were to run the test cycle again, how long is that going to take? Is it going to take the full test period? Probably not. Probably it's going to be 2 days or a week or whatever it is, if you have no problems. It's the fact that when you start, you find problems and you have to fix them. You're really debugging. That's what it is. And it's over this very short runway at the end. Now let's take a look at Agile development. What's the algorithm here? Okay, same problem. Facebook, Second Life, RSS feeds. 1 month iterations. We're just going to do Facebook. We're not even going to take into account Second Life and RSS feeds. If we have to make changes, we have to make changes. That's the way it is. Now, I've just done 1 iteration here. I had some problems and I fixed them. First advantage, higher quality. Now, I've done the second iteration and Facebook is ready to ship. I can ship it, I cannot ship it, but I have something that works, a known good point to go back to when I start working on the next thing, whatever it is. The market has changed. Marketing says, hey, let's have RSS feeds next. And we're thinking photo SMS is coming up, so just FYI. Options and flexibility is the second advantage here. All right, so you do the RSS feeds, market changes again. Now, Second Life, nobody wants it, and photo SMS is the next likely thing to do that you haven't already done. You do that. Next advantage, visibility. When you're working against a plan, you might say that you're 80% of the way through. You don't actually mean that you're 80% of the way through the project or the work that needs to be done. You're 80% of the way through the plan. And if that last 20% takes another 50%, then that's not real visibility. Agile, every iteration, you know, you're 1 more iteration through your overall plan. If you had problems, you know what they are right now, and you can take that into account. Okay, so now at the end, we have more of what the customer or the market wants. So that's the last advantage. I've got more ROI, and I can start realizing it sooner if I ship every month or every 2 months or a shorter period of time. You don't have to, because the value you get at the end is going to be much higher. Remember, in the traditional development, they thought there was a lot of value on Facebook, Second Life, and RSS feeds. Turned out not to be the case at all. There's much more value in Facebook, RSS feeds, and photo SMS. Okay, so a couple more points, and then we'll go on to the Q&A. So if you look at a traditional development, the architecture or algorithm here is that each capability that you have in your engineering team varies over time. And you pretty much need to hire to peak, or something like that, right? So you have a peak on planning and project management, you have a design peak, coding peak, QA peak. That makes it very difficult to know whether or not you have the right number of resources. It's difficult to do resource loading here. In Agile, they're going to be more or less flat because you have a team. If QA can't keep up with coders, you know, all right, I either need to have the coders write more unit tests or help more with test automation. I need to hire another QA person, or what have you. It's much easier to make those sorts of decisions. There's a better framework here for making management decisions, right? Because traditionally, I've got my releases, there's a problem injected, I don't know about it till just before the release because it's not until now that it actually has to work, and then I fix it later, maybe. I try to fix it later. Maybe it works or maybe it doesn't. Perhaps there's a person that needs some, a little HR help there or what have you. And once a month, people get the reviews and they're told they need to work harder or do something different. So the impact of whatever the problem is going to be long. And that's true for all the problems you might have. Now let's look at the same number of problems in Agile. every iteration, things have to work. If it doesn't work, I ask why. So the time frame is going to be shorter, and for the same number of problems, A, they're not going to recur, and the injection to find and fix is going to be much shorter. So problems are immediately apparent. If I take corrective action, I'm going to know pretty soon whether or not the corrective action worked, and I need to take new corrective action or not. If somebody has a good behavior, it's going to be encouraged and supported. Bad behavior is going to be discouraged and immediately apparent. So whatever your level of management skill is, if you're new or you've been doing it for a long time, is much better leveraged in this environment. You have more opportunities to apply your management skills. So in conclusion, this sort of technical comparison is what we do every day. So it's a good way to look at Agile versus traditional. Agile leverages people's strengths, and the code in an Agile project is designed to be changed rather than trying to avoid change. And the key differences in the algorithm, if you will, between traditional and Agile are whole teams, short iterations, the frequent feedback, customer involvement, and higher visibility. So with that, I would like to leave you with some things to learn more about Agile and go into Q&A, and I believe we also have a poll.
Yes, we sure do. So thank you so much, Damon, for an excellent presentation. So I'm going to ask you the first question. I'm going to launch the polling question, too. So the first one we have are, what are some good tools to support Agile development, specifically around backlog management and bug tracking? And do people use Microsoft Project for backlog management?
Excellent question. On the first one on the Microsoft Project, yes, people do use that for backlog management. God help them. People also use 3x5 cards and that sort of thing. Don't recommend it. It's not really designed for that. You really want to get something that was specifically designed with that in mind. A good example, of course, is an obvious one that's staring me right in the face here. Version 1 is very good at backlog management, so definitely recommend that. Other tools in this area for Agile development, of course, Agile for Agile SCM. And then some other things you might want to think about are build management, things like Urban Code, Electric Cloud, Cruise Control, Hudson, things like that. And they all work well together.
Excellent. Okay, so next question. How can Agile be set up for a small team that works on many projects concurrently when one of them is a continuous maintenance project?
Okay. That's one of those questions that contains its own answer, and it's not the answer you want to hear. So I'm sorry to say, one of the things that Agile says is don't do things concurrently. If you have, for instance, and if you look around for thrashing on the web, Agile thrashing multiple projects, you'll find a diagram along these lines. So let's say you've got 5 projects you're working on, and you work on one for a little, then you work on another for a little. One of those projects is going to finish, first, and then the next one, etc. The delivery time frame related to those is not going to be that much different than if you do the first project fully, the second project fully, third project fully, etc. And you're going to get a lot less. You're going to get a lot higher productivity from people thrashing less. People actually do very well with one project. A little better if they have 2 projects to pick up slack, and then it goes down sharply at 3 or more projects. It may be that that's due now. On the other hand, it may be that what you're saying is that you have little requests that come in over time, and you have no control over it. It's not like you have ahead of time what you need to do. In that case, I would suggest looking into something called Kanban, which is pull-based. So that team would be a project team with everything that they need in it for those projects, but the work that they do depends on what folks are asking for.
Very good. Next one is, do you have some best practices for transitioning? I'm assuming transitioning from traditional to Agile.
Yes and no. Where I've come around to is that if you think about transportation modes, let's say you're just starting out with transportation and your first vehicle is a tricycle. Obviously that took a little work. It made it a little easier to ride a bicycle, but not that much easier. And then riding a bicycle made it a little easier because you understand the whole left-right thing and traffic management when you drive a car. But best practice for driving a car is don't go through a red light. but of course there are complications. So with that in mind, there are some gotchas and things to watch out for. But I think the key takeaway here is to think about a transition to Agile development much the way you would moving from driving a car to learning how to drive a plane. You need to take it seriously. So the first thing is take it seriously. The next one is get some help. You may find that internally you have some experts. There are books, there are coaches, there are lots of options out there, but you're definitely going to need somebody that's done it before to really succeed. Now, can you succeed without help? Absolutely. The question is, a trade-off between the bumps and scrapes of learning to drive a car on your own versus having somebody sitting beside you and helping you out. So you also want to get executive buy-in. Certainly there are projects out there, Agile projects, that sort of hide out and pretend to be waterfall, but internally do Agile, and that can work. But getting executive sponsorship works. Getting as much sponsorship at all levels as you possibly can is definitely a good thing to do. So I'm not sure if those are really best practices, but I would say those are definitely things that I found have helped a lot. Take it seriously, get help, get executive sponsorship.
Thank you for that. We've got time for a couple more questions, so if there's anyone out there that's got any more, please feel free to type those in. Well, it looks like you did such a good job, Damon. There doesn't seem to be any more questions, so if you'd like to have any last words, please do so.
Okay. Well, I would say that the thing to do is to get started, really. Some of the books that I have here on the screen, The Toyota Way, which may not say anything about Agile, but it does talk a lot about Lean. And Scrum, for instance, is one example of how Lean can be done. And the book, The Toyota Way, talks a lot about car production. And I think it's a very interesting way to look at something and learn how somebody did something in a different industry. Building cars and building software are very different, but a lot of the things about waste and reducing waste and efficiency apply to Agile development. Also, even if you don't agree with pair programming or 3x5 cards, Ken Beck's Extreme Programming Explained is an excellent book to get you thinking. Same for the Scrum book by Schwaber and Lean Software Development by Mary Poppendieck. And in fact, for me, the Lean Software Development book was where I had that aha moment, because I may not have mentioned this before, but until 3 years ago, I was very much an Agile skeptic.
Well, again, thank you so much, Damon, for your time today and your presentation, and thank you all for joining us.
My pleasure.